Okay, so I think we'll go ahead and get started. People are starting to get the pizza. Last few people are getting their pizza and beers. Did we get the soda? Did the soda show up with some solo cups or something? Yeah. Okay, great. So for those who are, we try to cater it all. So those who don't drink beer, we have soda and solo cups. If you do drink beer, maybe have a beer first and then hit the soda after. Same principle applies to the vegetarian pizzas. If you're omnivorous, then eat the meat ones first. So welcome everyone to the February Austin Python meetup. Thank you so much. I was very excited to see how many RSVPs we had. I actually have to admit I was a little hoping that by putting the meetup description in a little bit later, we could actually reduce the amount of packing that we get, but it didn't help. So there's still a lot of people here. It's great. I'm glad to see everyone showed up. We are really excited. I think those who've been coming for a while can see that the community is growing. Obviously, anyone who's trying to park downtown sees that Austin is growing, more tech companies are coming to town, and a lot of those companies are using Python to do all their good stuff. So, really happy to have the community growing. To that effect, though, I would really like to put out the call for more people to help on organization, on getting some more structure around the meetup itself. I'll talk about that more at the end. And I'll have a few slides and throw things out for some ideas. But tonight we're very excited to have Kurt Smith talk to us about the new book he just wrote for O'Reilly about Cython. How many people here use Cython, out of curiosity? Okay, great. How many people have heard of Cython? Okay, yeah, look at that. Great. So this is going to be a very interesting talk. But first, I want to, as always, have a shout out for our sponsors. The pizza and the beer tonight are courtesy of Atlassian and Dave, right? Dave is here from Atlassian. You want to step up? And also the Capital Factory.
This is kind of last minute. We saw the call for we need a sponsor, and we're like, we definitely want to talk to some Python people. We are hiring actively here in Austin. I started relatively recently with them, but it's been pretty fun. If you don't know much about Atlassian, you may have heard of Jira or Confluence or HipChat or Bitbucket, things like this. We do all of those. HipChat development is led out of Austin now, and I work on the back-end team, a developer. And we're hiring top-end Python developers. So basically, it's really a fun company. Check it out at Atlassian.com/jobs. I don't have any materials. Don't even have my business cards. I'm a developer. What am I going to do? So, but anyway, please check it out. I will be here afterwards for the guy with the Manly Beach hat, and because we have the Australia office there. So Manly, look at his hat, and I'll be back in the back. And happy to answer any questions you might have. Thank you.
Yeah, thank you guys for sponsoring. And I just want to reiterate to all of you that one of the things we're going to be looking at this year is how we can better get the sponsorship cycle going so that we can be guaranteed pizza and beer and have our sponsors not get pestered every month by me or others like me. But definitely the sponsor will make all the food possible, the restaurants possible. Capital Factory is very nice to provide us the space. If you guys do go to the URL that Atlassian.com/jobs. If you go there and you submit a resume, please say thank you for sponsoring Austin Python. That's where I heard about the job opportunities. If you have friends that are interested in the opportunity, please tell them to say the same thing. That's what makes it possible for us to have more beer and more pizza. So, it's very simple value chain, right? Okay, so with all that said, turn it over to Kurt.
Thank you, Peter. So before I get started, there's an AV issue. I can't get the screen to come back up again. So whoever was helping me before, if you wouldn't mind troubleshooting, that'd be great. So in the meantime, I'll get the introductory stuff out of the way. So my name is Kurt Smith. I'm a developer at Empire here in town. Just block catty corner from here or so. And been a developer there for 3.5 years now. Before that, I was a graduate student at the University of Wisconsin. Studied computational plasma physics. Did massively parallel plasma turbulence simulations, that sort of thing. Used Python everywhere I could. Fortran where I had to. And loved the Python side and was ready to move on from academia after that. So I use Cython a lot, as you can imagine, given that it lets you tap into compiled languages very easily. And I also created a small project to try try to use Cython to tap into Fortran, modern Fortran.
So we're in the cabinet
Need some
factory.
sanity in my day-to-day work there. And so, yeah, in the course of that, I was able to land a Google Summer of Code project in 2009, working on Cython and implementing some new array features. Also working on some Cython and Fortran stuff, that sort of thing. And that got me really involved in the project, at least for that summer and following. And learned a ton about just general software development in Python, really software development on a non-trivial project. It's a full-fledged compiler. It's taking Python plus some extra stuff and generating C code out of that. And highly optimized C code, I might add. Really developing and working on that project really expanded me from just a scientific user of programming sometimes to feeling like, okay, I understand what this whole development role really is. So,
This is totally happening. You're going to be so screwed when
just 1 second. So, after that Google Summer of Code, I'm using Cython in my day-to-day work, grad school, and then went to Nthought, where I use Cython frequently in consulting projects and day-to-day work, that sort of thing. So, somewhat out of the blue, this book offer kind of just came up out of nowhere. I gave a talk on Cython at the SciPy, and it was picked up by some people who were already writing other O'Reilly books, and they just made introductions, made connections, and things kind of took off from there. So that's the story I'm telling you tonight. And I should mention that O'Reilly has provided some free copies of the book. I believe we'll be able to give out 1 copy to each person here tonight. So we'll have a raffle essentially. So Peter, if you wouldn't mind coordinating to some extent, or
I'm here.
Oh,
Sorry.
Isn't this a DisplayPort plug? This one here? Yeah, okay, he's ready on the DisplayPort.
Where it is?
Just try to unplug it and then plug it. See if that works.
I never saw the Cylons having this problem.
Just blow in the slot.
Yeah. Not quite at that level yet. There is actually, there's not
Okay,
HDMI
it
yet.
sees the sharp, it sees the sharp.
Okay. On the AirPlay or on the display?
It's right there, it sees it.
it was working.
Right, it showed up. Engagement.
If we
Okay, so it's actually connected. So is this actually on HDMI 1?
Yeah. The switcher's in the right spot.
Someone sacrificed a small goat or something in the back. All right.
Thank you all.
Okay.
So, by way of the raffle and such, if you're interested in a free copy of the book, we'll have a raffle tonight. So please write your name on a little slip of paper, give it to Peter right here.
What?
And afterwards, we'll be picking names from a hat. So if you cared about the book, you want one afterwards, stick around, and we'll see if your name is called, and it's all yours. So,
there are only 2 people with hats, right?
Those people have no one has paper.
Business
It's a
cards, that means
metaphorical
I'm here,
hat.
it's my hat.
Actually, why don't we do this? Here's a pad. You put your name next to it. Yes?
Use the vegetarian pizza rule. If somebody is interested in Cython, then they come get the book. If you're not specifically interested in it, then wait till everybody else has had a chance and then. So
Yes, thank you.
use the vegetarian pizza rule.
The vegetarian pizza rule. If you really, really want this book, please come up. If you feel like there's some reservation at all, then maybe hold back a little bit. I think we have 15 copies, so there's enough for a few. But
And it's like $20. Come on.
yeah, sure, $20. So it is free something or other. So okay, so How to write an O'Reilly's Python book in 100-ish days. This is how it all started. Email on January 1st, 2014, from Katie Huff, who just came out with a book with Anthony Skopatz called Leave. Sorry, Katie. It's involving Python for scientists, targeted specifically for scientists. So I will rectify this and get her, find the name for that book to you guys a little bit. But anyway, she was talking with Mike Lupides at O'Reilly, and in the course of that, I guess someone brought up the concept of Cython. She remembered the talk that I gave and put us in touch with each other. It was very kind of her, and just suggested maybe he wants to write a book. So January 7th, Mike and I talked about this previously. He, really nice guy, fun to talk to, fun to work with, and in this email he says, though I think 50 to 70 pages is the right ballpark. So just keep that in mind as we walk through the saga of this book here. Estimation in software is hard. I find estimation in writing books feels like 10 times harder. So the first commit was back on January 15th, starting on the proposal. And then the delivery of that proposal a few days later, about a week later. And here you can see already, I'm hedging a little bit. Finish the proposal, the outline is more detailed, blah, blah, blah. Right now the length would tend more towards the 75-page end of the spectrum. So I can already tell this is not going to fit inside the original format. And when Mike and I chatted about it, it's going to be really quick, get something out, it's going to be ebook only, just something, kind of just hit the highlights, right? But it's time, well, let me get ahead of myself here. So some setup stuff. O'Reilly has this authoring platform they call Atlas. I think there's a publicly released version of Atlas, which is more like for end users and consumers. There's also kind of like a author-only version of Atlas that you use for actually authoring the book. However, all I particularly cared about was a Git repo and being able to use Vim locally. Once I can have those two things, I'm happy. I guess possibly fiddly part of the whole thing was working with the ASCII doc format. Did anyone work with ASCII doc before? So I'm more used to RST or Markdown. But ASCII doc is just another Markdown syntax. It's significantly older than Markdown or RST. It has a lot more features, and it's fully featured enough to support everything you need for a full-fledged book. So that's why O'Reilly uses it. So there was a good amount of just getting up to speed on that. But besides that, my tool chain was basically, ASCII doc, editing files in Vim, using Git to coordinate with their server, that sort of thing. But of course, as you know, O'Reilly books, they all have an animal on the front. Before we get too far into things, we want to make sure that we have the important questions resolved. So before we get too far into the proceedings, the biggest question that may just be a deal breaker is who gets to pick the cover animal. This generated about a 20 email long thread. And there was lots of back and forth. All the good animals have been taken, apparently. So that was my concern. I really wanted a moose, but that wasn't an option. So it was definitely some backroom deals or something that went to happen, but what came out of it was a South African Python, which I was pretty happy with. I didn't expect a Python on the front. So that was nice. So then we got into the contract stuff. And I won't go into all the details. That was one of the harder parts of the whole project. It's more negotiations and dealings, and I brought in some relatives who are contract attorneys to help me out, and they said O'Reilly's really big, and we're just a peon. You want this book more than they want this book, so that's basically what it comes down to. So anyway, after the contract stuff was out of the way, which I was very pleased to have done, then started to get more down into the nitty-gritty of how big is this thing going to be, what the schedule is going to be, the delivery dates, that sort of thing. And you can see here I'm trying to lay out exactly what I anticipate. I'm still sticking to the 75-page limit, but I'm really trying to pin things down to like exactly how many words am I on the hook for here. And as you'll see, that was no issue whatsoever. And my original estimate was about 10 to 12 hours a week. And if you do some quick calculations, that comes out, I was estimating about 3.5 months. This was, beginning of February, so we're talking, sometime in the summer, how this thing wrapped up and out the door. So, got down to writing. 18th of May, 2014, delivered the first 2 chapters. And you see at this point already, first 2 chapters, I'm at 16,000 words. The book itself is about 13 chapters long. So I'm at 80% of my word estimate, but only about 15, 16% of the actual chapters. So this is already turning out to be much bigger than anticipated. And so, as you can imagine from my revised title here, it was more in the year range. And this basically summarizes that year. So we've got a heat map in the middle here. This is, each week of the year is vertically plotted. Each day of the week is horizontally plotted. So we have Monday at the bottom, up through Friday, and then Saturday and Sunday at the top. And if you stare at this for a bit, you'll see there are a lot more dark spots on the Saturday and Sunday lines than during the week, which, as expected, this is going to be a nice weekends project. So, and then we have the marginal sums for this plot. At the top here, that's kind of the weekly work done. This is just measured in words committed to the repo on that day. So you see, there's some. I was expecting it. So it's interesting. This little chunk in the beginning here, if you can see that. That was kind of when I was in the mode of, okay, this is going to be this many words per day, and just kind of crank out this very set rate of things. And if you notice too, I'm only working on the weekends here because it's only dark, on Saturday and Sunday, right? So it was very set, established. I had just this routine down, and it was just all falling into line. And then as you move on, you see, okay, there's this little break here. I don't know what's going on there. Nothing happened, I guess. Thinking, okay, what's happening? And then there's this blob of all this activity, and you see starting to work, nights during the week, and the activity rate is much higher. Some days where I check in 4,000 to 6,000 words in a particular commit, that sort of thing. So the activity just explodes. And that's really when the whole main book was written. So delivering lots of chapters in here, that sort of thing. Then it dies off pretty quick. And what this period is, which we'll see in a little bit here, usual flow for a book is you get most of the just raw content out, the first draft, and you're working with your editor to revise those drafts. And when that period's done, then they move right into tech review. And that's where you line up several people, some who are experts in the topic, some who are newcomers to the topic, and they read through, give you detailed comments, and you then incorporate those comments. So about here is kind of like I've got most of the first draft done, and then there's definitely a couple breaks where I don't do anything. And then after that, it's a lot of activity again. And that's all the tech review work. And that was a lot more work than anticipated. Then after that, well, again, I'm getting a little ahead of myself, but this year, just integrating everything over the whole year. This is words versus time checked in. And you can see easily these plateaus where no activity is going on. The first plateau is when the first draft is done. Then the tech review. Well, it's interesting, you can see kind of two slopes here. This is when I'm happily going along, blissfully ignorant of how much work is ahead of me. Then this explosion in the slope, really takes a new derivative here. That's when really all the work was done. Then I just stop, so I have to. And then catch my breath, go into the tech review stage, get all those edits in, then I stop again, gladly. Then there's this big blip, but that wasn't me, that was O'Reilly doing all their stuff. We'll talk about that a little bit here. And then if you add up everything per day per week, just all the Mondays, all the Tuesdays, so on and so forth, you get a feel for kind of the effort level. So Monday's on the left, and Saturday and Sunday are on the right. If you look at it, you probably can't see, but the upper level here is 30,000, so it's 30,000 words. So on all the Saturdays, it committed about 30,000 words. Sunday was about the same. This is just to say, this destroyed my weekends for an entire year. Friday nights, Saturday nights, Sunday nights, just the whole weekend was basically book time. And just so I could carve out time during the week. And I didn't separate out O'Reilly's commits versus my commits, so this would be a little bit more skewed if I separated those out. But anyway, so moving in pre-release and tech review, Robert Bradshaw was kind enough to agree to. He's the lead Cython guy. He's the guy who's basically kept it going from its inception and still does a great job keeping it going. He did a fantastic job with the tech review, just gave me lots of great feedback. As you can imagine, since it's his main thing, he had lots to say, including up to, you need to rewrite this entire chapter. And I did at least one of those chapters, so some others just big changes, that sort of thing. But his input and several other people's input really, the tech review process it adds so much value to the book, it's hard to describe. In this day and age, it's, O'Reilly's is a more traditional publisher, although they're definitely staying ahead of the curve or trying to in this new age where content comes out very quickly, and definitely concerned about staying on top of things and not getting out of date, that sort of thing. So there's a lot that goes into first deciding what topic to write a book on, and how big the book is going to be, how much development to devote to the book, that sort of thing. And as I mentioned earlier, when O'Reilly was first scoping out this book, they were thinking, okay, really fast, short time frame, ebook only, right? Because those are the things that let them just stay ahead of things. It grew a lot bigger than that, so once it grows a certain size and they start saying, okay, this is more of a print book, and print and ebook, of course. And so it's a long prelude just to say that it's for O'Reilly to be investigating into an area means that they're picking it up somehow, and they're definitely trying to promote it in some way. So anyway, so you can gather from this email here from Robert Bradshaw. So he says, very excited about this book. Don't take the volume of comments harshly. Just want this to be the best book possible. So it was a massive amount of work. So got all the tech review comments in, got it delivered on the 1st of November, and weighs in at 6,700 words at that point, and more than 3 times what originally agreed to. And I came across Leonardo da Vinci's comment, art is never finished, only abandoned. And that's definitely what it feels like even to this day, where, but I thought this was the final delivery. I thought it was over. But this is just the point at which I'm done with the first draft, essentially. Well, after the tech review draft, there's been a couple edits. And then O'Reilly's entire machinery kicks in. And that's when O'Reilly really takes it and just goes. And probably one of the hardest parts was, so they hand it off first to a copy editor. The copy editor goes through and reveals to me just how horrible my English is. And I honestly thought I was decent, especially like hyphenation rules and everything. And as you can see here, there's 1,617 edits that I had to more or less go through. They flagged ones that were important, that really needed input, that were more semantic changes. But, all the rest of them were just all these tweaks, just all over the place for things that I just got totally wrong, right? Or grammatically or whatever. And I mean, they're not sticklers for it. They want it to be somewhat conversational. They don't want it to be really formal or anything, but still, they want it to be, not jarring when you're reading it, or have these little things that people pick out. And it's amazing when you read a book and you read through it, and no matter what book, you're going to find some typos here and there if you're reading it closely, right? And I thought, what am I paying for if they can't even like edit this thing, right? But you realize there are so many little things all over the place. And I'm sure there were just dozens that still got through. But like copy editors and others, they provide so much value for the polish on the book and really make it a very smooth, make it read much better. Like I learned a lot in this process about how to tweak my own writing style and that sort of thing. Sentences, sentence construction, breaking things down. And so, yeah, it was, like it says here, a gauntlet to get through that. There's a copy editing stage, there's 2 rounds of that. There's a proofreading stage, which is much more just polish and tweaks and that sort of thing, but there's still a lot there. There's all sorts of, since it's a technical book, you have to worry about the code blocks. Are they formatted correctly? Are they technically correct? Are they going to run? Are they broken up correctly? If you're editing that, you need to be very careful that you don't break the code, that sort of thing. We'll talk about that a little bit more later. So finally, that was, when was that? I forget when that was, but that was all like November through December. Finally, January 9th, 2015, it's really, truly over. Congratulations, your book went to print today, and we've now completed production. And that print date is just fantastic, because once it's in print, it is locked in. You can't do anything else. It's a release, right? You can't, that's it. And since it's a book, no one's going to be running that code. It's not going to break. There's no maintenance on that book, right? So that's really nice as well. Although
there are errata.
Yeah, there's errata. That's true.
There's probably code in that book that you've got there.
Yeah, that's what I was going to mention. There is code.
You are so screwed.
So yeah, exactly. And that's the thing that I'm finding out is, and all the flurry of activity around the copy editing and proofreading and that sort of thing, you're going, yeah, I'll make this tweak and it's correct because I'm looking at it really closely, and it really makes me nervous because I know there are probably some code examples that are broken, and I'll probably hear about it soon. I hope I hear about it, honestly, because that means people are trying it out and using it and that sort of thing. But there is a GitHub link for this book, for the code examples, that sort of thing, so people can go there. It's all indexed to the book, chapters and sections and that sort of thing, so hopefully people can easily find what they're looking for. There's help on how to get this up and running, that sort of thing. And that's very standard, of course, to kind of have live examples that people can work with and play with. So yeah, that was the final date. So from January 1st, 2014 to January 9th, 2015, was kind of the brackets from very start to very finish. So what this book is about, so I'm not going to go into much detail on Cython itself. If you want to go in more detail, the book is there, or to give away for tonight. So, but Cython's interesting. It's Anthony Skopatz called it a Creole language. And if you know what Creole is like a hybrid language that's people are really speaking as their native tongue. So, there's Creole cooking in southern Louisiana. There's also Creole language, which is kind of it's a pidgin of French and English and Spanish and West African dialects. But it's like kids grow up with it, they speak it as their native tongue. So even though it's not inherited from one single language. So anyway, Cython, you can think of as a Creole programming language. It's got this pidgin of Python and C, C++, plus its own little syntactic tweaks here and there. And it is truly a language people develop in. Entire projects are developed, majority in Cython. So it meets all the criteria for a Creole language. And you can kind of gather from the fact that it is a Creole language, this blending of stuff, that it's very practical. And it's meant to address 2 questions. How do I speed up Python code? And how do I call C or C++ code from Python? So these are 2 things it's really trying to address. And I think these are somewhat separate ideas, but the interesting thing is Cython does both of these very well. And it does this by blending Python with C and C++. And you're probably using Cython, even if you aren't coding in it directly. All these foundational packages are using Cython. Pandas uses it extensively. Scikit-learn for one of the main machine learning packages in Python uses Cython extensively. lxml, may have heard of that. It's very popular XML package in Python. NumPy and SciPy also use Cython in important roles, but there are dozens, hundreds of packages that use Cython in either a small way to speed up one bit of their code or some massive way because they're wrapping some large code base. So quick overview. We have two functions here, top in Python, the bottom one in C. Top one, they're both implementing the Fibonacci sequence in a simple way. I'm using doubles here, floats in Python, just to do an end run around any questions of overflow issues in C versus large integers or Python longs and Python 2, that sort of thing. Anyway, so we have just a simple function, and what Cython's going to let us do, and you notice the C is much more brackety. It's conceptually is equivalent. You have a temp variable in there that you have to use, that sort of thing. But of course, there's all this infrastructure around the C to actually compile and use this thing. So we're kind of eliding a lot here. Cython, you just kind of take those two versions of Fib, one in Python, one in C, you just kind of mash them together. And you end up with something that, if you just tried to do this out of the box, right, you might end up with something not too far from this, where you type your integer now. It looks more or less like a Python function, except you're now adding a C type to your argument. And then we're adding this cdef int I to declare I as an integer, and we're declaring A and B as doubles, that sort of thing. But down here, it's still the exact same Python code, but because we added the static type information, the Cython compiler can kick in and generate very fast, efficient C code. So I'll give a demo here in a little bit, but I just want to give you the takeaway. Jump right to the money chart here. So we have 4 versions. These are 4 versions that I wrote for the book, just for this Fibonacci function. There's a pure Python version, top line, and then there's a pure C version that doesn't have anything to do with Python at all. It's just this raw, pure C function. There's a C extension module, so we're writing, we're implementing the Fibonacci function in C, but wrapping it so it can be exposed to Python, all by hand. And then there's a Cython version, which we saw. So then we have 6 columns, I guess. We're calling Fibonacci with the argument of 0. If you remember, we're looping through the number of times given in the argument. So this is not calling the loop at all, essentially. So this first column here, fib0, is measuring the runtime without looping for that version of the function. So it's more or less measuring the overhead associated with this version of the function. And you see, this is measured in nanoseconds. This column here is the speed up, the relative speed up to Python. The pure C version is 300 times faster, just for basically calling and exiting that function, essentially. The C extension version is 3 times faster than the pure Python version because it still has to deal with Python objects, extract the C bits, call the C stuff, and then create a new Python object out of the result. And the first interesting bit is that the Cython version of this, it still has to deal with Python. It takes a Python integer argument, extracts a C integer, passes that into the C stuff, returns a new Python double as a result. So there's still Python at the beginning, Python at the end, but the Cython version is already more than 2 times faster than the handwritten C extension module. So Cython does a lot of work to really make the overhead of calling a function as efficient as possible. So it's trying to, and this is something that you find a lot. Cython takes a lot of pains to optimize the Python C interface as best as it can. This column here is fib90, so now we're looping through 90 times, so it's actually running some of that loop. Python version is much slower, and the other versions take a little bit longer as well. The speedups change accordingly, but the speedups are now closer to each other because we're actually doing some computation here. And these 2 columns here are basically just subtracting the fib0 times from the fib90 times. So basically subtracting off the call overhead from the computation part. And the takeaway here is this last column. The speed up for the loop body part, they're all basically the same. And if you run this a bunch of times, you'll see them all line up right about the same in the mid-70s or so. And what this is saying is that if you account for overhead, Cython is generating code as fast as pure C or a handwritten C extension module. So basically, ignoring or accounting for translating things from Python to C, Cython is giving you very efficient code. All right, so that's all I'm going to say about Cython, the language. Again, there's a book if you want to go into more depth. So what I learned along the way about technical writing. So found 2 quotes here. What I would do in my time I just could not write anymore is I would look for quotes. And I found some good ones, and I tried to make the quotes somewhat relevant to the chapters that I was writing. So I put these 2 quotes at the beginning of the chapter. I forget the name of the chapter, but it's a chapter where I talk about getting Cython working on all platforms. So it's particularly on Windows, I think it can be a bit challenging to get working. Just talking in very general terms about the value of good documentation, right? I mean, we're all developers. We turn to documentation in some form or another all throughout the day to just figure out our way through code base. Python spoils us in relation to other languages. We have doc strings, we have Elastic Online resources, that sort of thing. And who has ever used Swig before? Okay, distinct minority, that's surprising. Anyway, so Swig is who has heard of Swig at least? Okay, a bit more. So Swig is another one of these wrapping, well, Cython and Swig overlap in that they both wrap and expose C, C++ code to Python. Swig's interesting in that it can wrap C and C++ for a whole bunch of front-end languages: Ruby, Scheme, Common Lisp, Python, of course, JavaScript, C#. It's this amazing project. It's been around since the mid-90s. People use it for all sorts of stuff. But it's the main specific language that you're using for Swig, and it's very, you can do all this very powerful stuff, but when you get into advanced usage of Swig, it's just really hard to use. And I'm convinced that the one thing that keeps Swig around, people just don't abandon it altogether, is its fantastic documentation. Because it sure is not the Swig language itself. There's no way people would ever want to use that. But the documentation is magnificent. And even Dave Beasley, the creator of Swig, said, Swig type maps, this thing that you use all the time to map types from one to another, they make it easy to blow your whole leg off, not to mention your foot. So they're very easy to just mess up and screw up. But the documentation is so great because it walks you through all these edge cases, so you at least have some chance of figuring out how to use these things correctly. And I mean, if you go to swig.org and look at the documentation, it's just like massive, because they have to in order to comprehensively document this thing. And the point I'm making here is that documentation can account for, really bad design, and can really make up for a lot of things that are bad in a project. And it's not to be discounted at all. So this is going to be somewhat piecemeal part of the talk, just kind of jumping around a little bit. Good documentation, very important. Don't think there's any controversy there whatsoever. When you're writing documentation, whether it's doc strings, which is very low level, up to developer documentation, up through like more formal documentation such as a book, your audience always has to be in mind. Right? Again, not terribly controversial. But especially if something's very formal or a bigger piece of documentation, you have to think about all the different ways people are going to be using your documentation. Some are going to be coming at it as brand new users, so you have to think, okay, who are my brand new users? What can I give them so that they're not totally lost or there's too big of a jump, that sort of thing. At the same time, you don't want to go too slow on every single part so that it's just plodding along at such a pace that your intermediate or advanced users just drop it because they don't care. So that's one kind of 2 bounds that you have to care about. People are going to be using it as a guide and reference material, so they're not going to be reading it end to end. They might even just be searching through the online version for just some keywords. So you kind of have to think about, okay, how do I break this up so that each section is more or less self-contained to the extent possible, right? If you did that everywhere, it would read very choppily. So there has to be some flow to it. So that's another kind of constraint you have to care about. You know, maybe kind of searchable and reference material versus more narrative style. You'll be using it for recipes and patterns, so they're going to be saying, I know I need to do this thing. You could wrap some C++ code that's using smart pointers and Cython, right? So they might search for it, and if they find like a pattern that you've already established for them, and they can then take that and use it in a way to kind of adapt it to their use case, then that's useful as well. So you want to have fairly complete examples. And people are also going to be using it, they're reading the book to say, do I want to even use this thing from the start? So they're kind of looking at a very critical point of view, right? Sometimes your audience is people who are just trying to snipe at every chance they get. So you have to keep in mind like other alternatives that people are going to be using and how you can address those concerns at relevant points. And one of the best bits of advice I got, or I forget where I read it, but imagine a very specific person for the section of the chapter you're writing. You know, have in mind, kind of get a kind of character study in place for, okay, this is the person I'm targeting, these are the people I'm not targeting, so that you don't get this very kind of shotgun approach, which kind of jumps around a lot and is too scattered. You want to have something that's feels consistent, and based on the chapter titles and content, that sort of thing, people get an idea of what chapter is designed for what. Okay, so one thing that struck me while writing this was repetition when writing documentation. I'm sure we've all heard of the DRY principle. Who here has heard of the DRY principle? It stands for don't repeat yourself, right? And it's one of these important principles in software development that you don't want to have duplicated code anywhere, right? Because the risk is you duplicate something here and here, you go back later and tweak something that's wrong in the first version, and you forget about the second one. There's just this bug lurking, waiting to strike. So that's an important software principle, but if you apply that to writing, the writing can be horrible. If you have one canonical place where you tell people, I don't know, some really important thing about Cython. I'm blanking right now, what would be a good example? But, I'm sorry, what's that?
Repetition.
Repetition? Oh, thanks. I misspelled repetition.
Copy editing.
Yeah, copy editing. I need someone to copy edit my slides. So,
So you wanted one important thing about Cython?
what's that? Yeah.
All valid Python is valid Cython.
Yeah, thank you. All valid Python is valid Cython. It's an important thing to remember. That lets people realize, oh, I can just take my Python code, throw it at Cython. You just give it a .py file, throw it at Cython, it will give you a boost, right? It's something that we want to repeat somewhat frequently in this book in different contexts where it's relevant so that people are aware of this in case they're jumping around or that sort of thing, right? We wouldn't, if we're doing software development, we wouldn't want to repeat that. We would have one canonical place where we represent that bit of information, and we would refer to that in our code base. But in a book, you repeat stuff, but you can't just rote repeat things. It has to be in context. And so what I like to think about is the representation of the same concept just in different forms. You can do that just in describing it in general. So you're kind of telling your readers what this thing is, and then you can demonstrate it in different contexts. You can do it in like short little code examples in line. You can do it in larger chapter length end-to-end examples where it comes up, that sort of thing. So this idea of representing the same idea in different ways to kind of solidify it so they see it from different angles was an important thing that kind of guided a lot of the writing. So here we have Stephen King versus Garry Kasparov. And I do a horrible job of referencing the things that I read things from. I can't find this one though, I wish I could. But I read this software engineering study that studied people as they were reading code. And I think they even looked at like their eye movements to see exactly where on the screen they were looking as they were trying to understand a code base. And what the expectation was at the beginning was people just kind of start at the beginning, read through, more or less, maybe jumping back a little bit, and just get an idea of what this code does. But in actuality, they saw their eyes jumped around all over the place, just back and forth, back and forth. And what they compared it to was looking at a chess position, where you're trying to figure out the relationships of lots of complicated working parts. It was not like just reading prose, right? Reading code is somewhat of a misnomer. It's not like just starting the beginning, reading to the end, right? You have lots of little functions and they're all calling each other, that sort of thing. You're going to want to figure out, okay, how is data flowing through this? You might have to jump around, dig into called functions, that sort of thing. So you're going to be jumping around a lot. And so, and it doesn't matter what language this is in. Python has a lot of nice things about it, but you can obviously write, equivalent Python code to C code, and they can have lots of nested functions, that sort of thing. So you're going to be jumping around a lot to just get a grasp on what's going on here. So how does this affect technical documentation? Well, so this may be somewhat controversial, I don't know. With some people, when they're writing, so I guess as a backup, when I was writing this book, something you read every other technical book very differently when you're writing a book. And you look at how they're doing examples, how they're, how big are their examples, what things they choose for their examples, how they just handle the whole thing of like mixing prose and code, that sort of thing. And one thing I noticed is a lot of books just give you a massive code listing, dozens and dozens of lines. And there are benefits to that. They have inline comments, that sort of thing. It's, my feelings on this are that because code is more like looking at a chess position, it's more helpful to the end reader to break up these code examples with prose. So you guide them through the design, what's going on, that sort of thing. And to provide access to the source code outside of the book, so they can go and look at the raw source code and run it as they like, so they have access to both options. But the book itself is breaking things up into little snippets and kind of digesting things for them. So, just kind of while we're on the topic of examples, one thing I found while writing this as well, finding good examples is probably the hardest part of writing anything in technical documentation. If you have a crappy example, def foobar with a baz and a boot and a Cook's argument or whatever, right? People immediately just drop out. They don't care about your example anymore. Yes, there's this pattern here, but they need something to engage with this example a little bit. There needs to be something that's mildly interesting about it, at the very least, just so it's not boring. And so that they can say, okay, this is something I can somehow imagine it being useful in my context, right? Because people are reading this book because they ultimately want to use this thing. It's not some abstract thing. They really, practical focus is kind of the name of the game here. And a great example satisfies all of these criteria, probably a lot more. It's not too domain specific, but it's interesting enough that people can engage with it. It builds and expands, so you can kind of say, oh, look, we can add this bit, and look at what we can do now, and it's all kind of, all the work they did to understand the first version of the first little skeleton that you gave them kind of just grows to accommodate more functionality, and you can kind of really build on it. And if you get a great example, you can basically write an entire chapter on it. And it can be deceptively simple at first, and it can really just grow and grow and grow. So one thing I found towards the end of the book is focusing on examples first, and using that as kind of the driver for my chapters. And that, I think, really helped at least, figuring out things. And there was this whole graveyard of failed examples that just didn't work for one reason or another as you're writing this. One thing that I found as well is the computer benchmarks game. They've got all these different algorithms and programs, and they've got all these different versions in all sorts of languages, and people submit versions of it and they compete, and you can compare like Python to C or any language against any other language, and you see it broken down, like memory usage, runtime, lines of code, that sort of thing. So those made really good examples, like chapter length examples to just go into. Okay, it is in Python, here's a runtime, and let's move this to Cython and see if we can get to the C performance, but still keep it more or less looking like Python, right? So there are a couple of chapters like that in here. So that wraps up the slides part, but my editor wanted Peter and I to make sure we plugged O'Reilly a little bit, and more just saying O'Reilly really wants content and people to come to them with new stuff and all sorts of things, not just book length stuff, but notebooks, how Python's using enterprise large companies, what else? Python best practices, the top N mistakes Pythonistas make doing text, Python graphics, so on and so forth. So if you have kind of something in the back of your mind, and if this talk has not scared you off about the level of work involved, then it's a fantastic experience. Like, it really was a lot of fun. And we learned a lot. It's a different perspective on software, and you definitely have more, okay, I'm wearing the hat of someone trying to use this thing rather than developing on it. And it changes how you perceive software from that point forward, what the things you care about, the things that are important. So, yeah, those are the slides essentially. I wanted to give you a quick look at what Cython can do. So we have here an IPython notebook, and IPython's done a great job of making sure Cython works within IPython notebooks. Again, the caveat that on Windows it's a little bit harder to get this set up, but you can still do it. There's this Cython extension, and you load that. You can do a %% Cython in a IPython cell, and let me pump this up a bit. It's a little better. And inside the cell, now you can just put raw Cython code. So we have our fib function from before. When you evaluate this cell, IPython will basically take the hash of this string of code, see if it's already compiled. If it has, it'll just load that version that's already compiled. If it hasn't, it'll recompile it into an extension module, load it for you automatically, and then you can just call fib from your next cell here. And they're out of time, but if we were to, we could write a pure Python version that does compare the runtimes, that sort of thing. So the nice thing is that IPython makes it very easy to interact with Cython just in an exploratory way and integrate Cython code with your other bits of analysis, that sort of thing. So anyway, thank you very much. Appreciate your time, and please let me know if you have any questions.
So, something that Peter said, he said that all valid Python code can run on Cython.
Yes.
So, where does it break? And if so, why aren't we just using Cython all the time and not calling it Python? Where are the differences?
Good question. So the question was, so since Cython can compile and run just pure Python code, the question is first, where does it break? Secondly, if that's the case, and if it can handle all Python code, why don't we just use Cython everywhere? Why don't we just basically, you install Python, you kind of bootstrap into a Cythonized version of it, and you just run based on top of that. And I don't know all the reasons why. I couldn't give you the full breakdown. But I understand there are some advanced Python syntactic components that aren't yet fully supported in Cython. I know the list is very small. Python always is growing and adding new features. If there are new syntactic things, Cython has to implement those, that sort of thing. So there are some particularities of C-level semantics that do kind of leak into the Cython code. So it's not everything will be identical. Like if you take any general Python code, there are some things you can do, like with globals and that sort of thing, that you might get different results in Cython than in Python. They're well documented. Cython will emit warnings for those things, so you're aware of them. When you're compiling, that sort of thing. You can turn them on or off. You can make it more strict to say, make an error at this point. So it's very careful to make sure that those things don't break your code. But there are differences there as well. So there was a time when Cython wanted to be part of the Python standard library, and they were pushing towards that. And as Robert Bradshaw told me, he said he sat down with Guido one day, and Guido told him, "You don't want to be in the standard library." He said, "Standard library is where packages go to die," as he put it. And Robert, after a while, tended to agree with Guido on that point. Just you're on a very strict release cycle. You don't have much flexibility. You have to support a lot of stuff, although Cython is very stable and very much cares about backwards compatibility, that sort of thing. There are, Cython, when it installs, Cython compiles itself. It's a huge Python code base. It compiles itself into Cython. So you run Cython, the compiler, it's running Cython generated compiled code. So it's using that as kind of a self-test, and very large, non-trivial libraries are doing exactly what you described. So, but the real fundamental reason, I don't know. Other questions? Yes.
Are you taking Cython questions or just book writing questions?
Oh, Cython questions are welcome as well, certainly.
So I'm looking at your fib function there, and the point you made is everything from the 4 down was straight Python. And so all it seems that you're adding is type information. If you took that type information out, what would happen performance-wise to that Cython function?
Good question. So the question is, so this version of fib here has type information, and that gives you good performance. If you were to take this information out, hold on. So just commented on all the type stuff. So now we're basically back to the pure Python version of this function. No typing information injected at all. It's still compiled, it'll still run as well. Oh, sorry. Thank you. Demo effect, 1 second. I believe that's what I had before. So we evaluate the cell. Okay, so it still runs, still works. If we were to go through the steps of measuring the runtime, you would see a slowdown, right? If you were to compare this, so this is pure Python code compiled by Cython into an extension module. Cython has to be safe, so it will not add as much typing information as we had before. So because of that safety, Cython's not going to be able to get as much speed out of this, but it will give you a speed up over pure Python. And Cython is able to figure out, for instance, since A is assigned to the literal 0.0, Cython does, and because A is just assigned to other doubles down here, Cython does have enough intelligent type inference, runtime type inference, dynamic type inference, I should say, to realize, okay, A is a double, and it can be a double the entire lifetime of this function, so I'm going to type it as a double from the start. So there is some nice type inference that Cython will do. It's very conservative and safe. You can say, no, do it much more aggressively, put some decorators on that thing, that sort of thing, if you want. So they've been pushing in the direction of more dynamic type inference to address some of these things to really speed up things as best it can. So I guess the takeaway is it will be faster. It won't necessarily be as fast as when you add type information. There is, I should mention, a pure Python mode in Cython. People tend not to use it as much, but you can basically take a .py file, import a special Cython module into that, use decorators in Python, valid Python syntax to basically describe to Cython, this function takes these 2 arguments, it should be a Cython integer. You don't use the cdef int syntax, you use Cython.locals and then Cython.int. It's all valid Python syntax. When you run that as pure Python just ignores all of that Cython stuff. It's just as if it doesn't even exist. It's just there, it's just no ops. When you give that to Cython to compile, Cython will take that information, and it's equivalent to this version here, it's just different syntax. So that's one nice way to have one code base. You can compile in Cython, get speed ups, or just run in pure Python mode if you want. So, other questions? Yes, Andy?
So one, do you know if Cython supports type annotations from 3.3 or whatever? And
yes,
it does. And do you know? So my understanding is MyPy is starting to be added to the standard library.
Mm-hmm.
So the whole argument that Cython shouldn't be seems a little deflated now.
Yeah, good question. So the question is, one, type annotations in Python 3, the Python 3 syntax of adding some optional type of information to the argument types and the return type of a function. And the other question of MyPy and that being kind of rolled in and kind of hooked into this type annotation stuff as well, right? It'd be kind of the standardized way that we describe types in Python, right? And why doesn't Cython?
Yeah, well, I mean, so that's happening. Where's Cython fitting in that?
Yeah, I don't know for sure what the core developers are thinking on that front. I have not been a part of those discussions at all, or if they're there, I've not seen them. So I couldn't say it definitively why. Cython has its own type syntax, right? Its own type hierarchies, its type structure, that sort of thing. So.
Travis had an answer.
Oh, yes.
I don't have a definitive answer, but I know certainly some of that came out of the EuroPython discussions. The interest from the Python core devs around MyPy is more about type annotation and inference for code correctness, not for speed.
I see.
I don't know if they're actually going to do anything to compile it or create faster versions. It's really more about making sure that your code, somebody calling a function with a certain type, they can give error messages and IntelliSense can work better.
I see.
So, but I think once that starts, there's going to be, there's certainly the precedence is there. People are going to start wondering about, okay, now how to make this faster. So, but then the question we revisited. Robert Bradshaw may have had that. I had that same response from Guido when we talked about NumPy, getting NumPy into Python. Same response, right?
Oh, yeah.
But there comes a time when it's like, well, maybe it is time. So,
yeah, thank you. So Travis's comment was the MyPy, the main thrust of the MyPy typing syntax is more correctness rather than speed. And Cython, of course, is using typing for speed and also for correctness as well. But speed is one of its main thrusts. So there's somewhat of a mismatch there. But any other questions? Bob?
So Cython isn't 1.0 yet, right? Is there something it's waiting on for 1.0?
Good question. So question is, Cython is not at 1.0 yet. It's at 0.21 or 22 now. And what's stopping it from releasing 1.0? I asked Robert Bradshaw that in the course of this book, thinking about, okay, future versions of this book, revisions, stability, that sort of thing. And he indicated there's still some things he wants to do that are potentially, keep coming out here, things he wants to do that are potentially experimental or edgy. If they work great, then they'll roll it in. If they don't yet, then they'll, rule those out. He indicated it's almost all the way there. And he did indicate he's exploring some new. So if you've worked in C at all, who are a C or C++ programmer? Okay. So you can get some, to describe a C function that takes a function pointer and returns a function pointer of arrays of function pointers, right? It's just this absolutely twisted way of declaring that type in C. And I don't know of anyone who can just whip that out easily. Right? Other languages, you can describe very complicated types like that in a much more straightforward way. So Cython, given that it understands both C types and Python, it has to understand and work with all that. But of course, people using Cython come from a Python perspective. So Robert was saying he wants to add maybe an alternative typing syntax, another typing syntax. That would be perhaps like languages he was interested in, like, I forget what he was referring to, but they have a bit more straightforward syntax is a bit easier to figure out. So again, I didn't get all the details, but some other things that he's looking at implementing. So beyond that, I don't know. It seemed fairly loose as well, like just, okay, well, we'll see, so it's very open-ended as far as a 1.0 release. Yes?
Continuation to this question. Whatever is there from your experience, how stable it is, and also how can we get it? Like, we have to download this version of a package. Does it come with some distributions?
Yes. So I did a very poor job of showing you how to just get Cython and use it, that sort of thing. Cython is so pervasive It's used in all these fundamental packages, and it's just part of all these very standard distributions.
Give me names.
Well, Anaconda, for example.
Okay.
Or it's Canopy, or Python XY, or, I don't know if, in fact, I'd have to work hard to find one that doesn't include Cython. So it might be a somewhat out of date version, but it's still there. And pip install Cython will work.
And the versions that are there, how stable are they? Will they break in some conditions? Because you were saying it's not 1.0 yet.
So the question is, the versions that are there, how stable are they? Will they break in some conditions? The only thing I know of is, I'm fairly confident in saying they're backwards compatible, always. They have an extensive test suite to make sure that's the case. And each new version either just adds performance improvements or supports more Cython syntax. So it's always just growing or getting better. It's never contracting or breaking stuff. Yeah, that's about all I can say. Yes?
What's testing like when using Cython? Can you use standard tools? Do you have to
good question. So the question is, how do you test Cython code? Cython has its own test suite that, of course, is compiling a lot of code and wanting to make sure it tests that. And it made sure that it could hook into like docstring-based tests, was one example. Cython can ensure that it exposes its Cython version of functions to testing utilities so that they pick them up and run them just like any other thing. So I should say doc test-based testing will work. We have embedded tests in the doc strings. That works. If you can set up a fairly standard kind of unit test framework that uses Cython. If you're developing a project that has Cython code, there's of course this compilation step that has to happen before, when you modify that Cython code, you have to make sure you compile it into an extension module now. You can't just run it as like a regular Python project, although there are ways Cython can trigger that compilation automatically at import time, so you don't have to think about it that much. We go into all that in the book. Cython tries to get out of your way for quick stuff, but it also can be very much industrial strength, where one of its main use cases is Cython doesn't want to force you to have Cython installed in order to run and use Cython code. So one thing a lot of people do is they'll develop using Cython, generate the pure C extension modules, and just ship those without Cython at all. And then the end users will download and compile it for themselves, or you can of course create a wheel binary components, and but Cython gets out of the way as fast as it can. It just gives you like the raw thing you need to build and run. So, okay, one more question? Yes?
Are any C tools supported, like GDB? Is there a lot of name handling and design?
Good question. So if you ever open up one of these Cython generated files, you'll be horrified at how mangled everything is. I don't know why Cython does this. It's a holdover from its parent project Pyrex, which Cython forked a while ago. And so Pyrex had this name mangling scheme, and Cython kept that, and it's Cython also emits highly. I've learned a lot about optimizing C code by just reading Cython source code about what things you can do. Cython's C code is extremely portable. It takes pains to work with all sorts of compilers all over the place on all platforms. In terms of debugging Cython code, that's its own topic in and of itself. I wanted to have an extensive section on that in the book, although it was getting way too in the weeds. I did give some pointers in it about that sort of thing. But cross-language debugging is hard. It's just plain hard, no matter what tools you have, to cross that language boundary and to say, okay, this Python function here is jumping into C, and now I'm in C land, and I can jump back to Python, that sort of thing. There are some nice Visual Studio components for doing that sort of thing. You can, of course, just fire up GDB and give it the Python interpreter and say, here's, when it starts loading stuff, you can put in debug breaks into your Cython code, that sort of thing. There is a experimental part of Cython called CyDB, like GDB, but for Cython. And it's interesting because it generates stuff so that you can more easily do this cross-language debugging with GDB. although it uses some advanced GDB features, wasn't very bulletproof. I couldn't put it in the book just because it was falling over so much. So it's really just a matter of development time being put in on something like that to really move that forward. So it was working at one time, just it's not then maintained though.
GDB4. GDB4.8 has a Python cross, so we can do Python C.
Oh, cool. So Andy tells me that GDB 4.8 has a cross-language debugging feature that can jump into Python and C. That's neat.
What about PTBS? It's like debugging to other. Do you know if that works well with Cython?
I've just used Visual Studio's general cross-language stuff. Actually, be hooking into PTBS. So yes, I have. And it is very nice. It's a little hard to set up, but once it's there, it's great to just set a breakpoint here and just see, go back into Python, callbacks, that sort of thing.
I think we should probably.
Yes.
Thank you very much, Kurt. Yeah.
We'll have to sacrifice another goat. So yeah, like 15 books, is that right?
Yes, that's right.
So first things first. Hello. The 3-day startup announcement. Hello. Did you want to make the announcement of the 3-day startup? So one announcement, and then I'll do a little spiel, and then we can all go somewhere and invade some bar.
Anybody here heard of 3-day startup? Any alumni of 3-day startup? No. Well, okay, this is as good as time to say. 3-day startup is a program that is it's taking place all over the world, but we have a chapter right here in Austin, and it's aimed to get especially students, but not necessarily students, people who have no or little experience with startups, to make their own startup within a weekend. It's 72 hours of just nonstop working, and it's free food and everything. It's fun. It's a great way of actually incubating new startup ideas and such. If we're both looking for people to participate more in the program, we're trying to reach out to more non-student-based communities and also for potential sponsors for the program. So if anyone has any potential ideas on this,
Your name and email?
just I'll leave it with Peter.
No. Just say it right now. I don't want to be the middleman. Say it right. Say it right now.
Yes, you want to be the middleman.
No, it does not. I charge for that. I have a billable rate. What are you talking about?
Okay, my name's Ian. Address is at iantgeorge.utexas.edu. If you want to look up more about the program, I also have the contacts of the guys who run it, and we're really trying to get an incubator here in Austin, ecosystem that gets out more to people who might not necessarily, they're interested in startups, but they don't know exactly what to do. So, yes?
About of Startup Weekend, because it seems that you're doing the same thing. What's the difference?
They have a network. No idea.
They have global network. Check them out. Startup Weekend.
Well, anyways, if you're interested, just let me know.
Great, thank you. Ian George at utexas.edu. Okay, so one thing we're going to do here is we're going to go ahead and do the book drawing before we forget. Woo! Oh, come on. And we're going to do it just to prove to you guys that I'm not doing anything funky, right? This is not Cython. We don't need to Cythonize this because Intel works hard, and AMD and everyone else, to make our chips fast. Okay, so I don't take a position on the hardware side. So we're just getting a list A of 44 numbers because 44 people put their names down. I like the vegetarian pizza concept, but it occurred to me that the Warcraft loot model should have been better for this need versus greed. But unfortunately, that occurred to me halfway through this talk. So 44 numbers corresponding to 44 names.
Is the names on the list zero indexed?
No. I took care of that by starting it with number 1, because we're people, not computers. So random.sample in the Python standard library is a random module. It's very nice. Sample will select, in this case, we'll select 15. Oh, well, this is something I ran already. I guess I hit enter. Let's do it again. Okay, so everyone's someone knows their number. Now, unfortunately, I think in the interest, because I could have just like pasted that in or something. We'll do it again. I'm sorry, we'll do it again. Yes.
Source to that as well, please.
The source? Oh.
Sort.
Oh, sort?
Yeah, so we'll have to look at it twice.
Yeah.
Sorted.
You want to sort
Sorted out.
I'm doing it. I can do this. All right. One-handed. All right. So, number 1, Ashley McNamara. Ashley, woo! Oh, she's back there. All right. She's our Capital Factory person back there. Number 3, Jonathan Satterfield. Yay. You guys don't have to clap. We clap at the end for all 15 people. Number 6, Tui, how do you pronounce this? Papano, all right. And number 11, Samuel Harold. Number 15, Abby Baskaran. Great. So 15, 19. Less?
Yeah.
Okay. 21, Dimitri Meyerson. Is that right? Awesome. 23, Aaron Muir.
Yeah.
Aaron, really? Where are you? Okay. Again, need versus greed. Need greed next time, all right? We're going to set the rate settings here. 23, 25. How many people here play Warcraft or have played? Show hands. We'll admit to it? Okay. 25. David Kuhn.
Okay, I still pay.
You still pay. There you go. I'll talk to you later. I want to know what kind of character you play. Okay, David Kuhn. Got it? Okay. 25, 26. Tennis. Luna. 29. Greg Brenner. 31. Eric Adams. 33. Ben Christensen. 37. Ian George and Scott Kirkland. Oh, they're gonna have to split the book in half. All right, and then 41 is Mars Wright.
Did I miss someone?
Oh, Ian George and Scott Kirkland?
They're on the same.
He's like, yeah. Wait, did you put your name separately?
Yeah, different handwriting.
But you're 38 then. I'm sorry, 37 is Ian George. You didn't put a number next to yours. But the next person incremented correctly, so this is good. Sorry. So 37 is Ian George. 41 is Mars Wright. I'm sorry. No, I just didn't. Yeah, I thought you guys were like a combo ticket, powerhouse. Okay, thanks everyone. Now, again, I'm standing between you and the pub, so I'm gonna get. No, that's not what I want to do. I'm gonna get this going really fast. So basically, we are kicking off. This is February. This is sort of, we're just getting started in the year. It's gonna be a really exciting year. As you guys can see, the awesome Python community is growing. I came up with some slogans. You guys come up with better ones. But I'd like to actually sort of talk about a few things about how we can grow the organization, improve the sense of community, and sort of really, we're one of the largest. So here's the thing. I got this out of order. First announcements. Next month we're in the other room, and we're gonna have much more limited space because it's SciPy, and Capital Factory is still nice enough to let us use the space, but we're not gonna be able to be in here. But the parking will suck, so many of you will not want to come down here anyway. So I hope it'll work itself out. It always does. The other thing is, someone from New York City Python Meetup reached out to me. She said that I forgot. I think it's Tatiana. She wanted me to just tell everyone at this meetup about this thing she did about learning fundamental programming in Python by creating a virtual Tamagotchi pipette sort of thing. Who knows what a Tamagotchi is? Oh, good. I'm not that old yet. Okay, so the idea here is this right here is about how you basically can learn programming just by doing the kind of basic stuff. She said it's had good traction in your community, so she wanted me to get the word out about that. So now I have. So what I was going to say was, rehearse your slide deck first. What I was going to say was that we're growing as a meetup. We have 1,800 members now, which is pretty cool. I remember years ago, the Tribune, when we had 512 members, it was a big deal. We're at 1,800 members now. Not everyone is here tonight, But many people actually, the faces do change every week or every month. And we have sister meetups, right? We have Austin Web Python, PyLadies, Austin Web Python. Let me go ahead and show you the, hope everyone is at least aware of these, and this is not the first time you're hearing about it, but let me go and click on the other tab. What? Okay. There's Austin Web Python, and that's the last Thursday of every month. Austin Learn Python meetup. They kind of meet further out on 360, but it's a really great sort of very structured way. If you're getting, if you're getting into Python the first time, if you're learning, if you want to mentor and teach to improve your own knowledge of the subject. Great organization. PyLadies is a fantastic, vibrant organization as well. I actually wasn't aware of the PyBombs sort of concept. This is great. So we have a lot of meetups here under sort of in the Python community in Austin. And so the question sort of is, we can sort of kind of keep doing this and being very organic and just kind of just naturally growing. But I actually had a really fortunate meeting with serendipitous meeting with Brian Ray, who's the author of Chicago Python, Chippy. I know at least one alumni here, but certain others people here, maybe alumni from there. And they're one of the preeminent Python meetups in the country and the world. We're actually one of the larger ones. But nonetheless, I think some of the other ones like Boston and Chicago have much more structured organization around them. So what I would like to do is get people thinking about and propose the idea of having kind of more structured organizing committee. We already have an organizing committee for Austin Web Python, and we're sort of all on the same mailing list and stuff. But I really want to involve more membership in guiding the evolution of the meetups. I myself am getting really busy. I missed, I think, 4 meetups last year. And so, I'm just not able to do it sort of just by myself anymore, and I lean on many other people, Andrew and others, to kind of MC when I'm out of town. But I want to make it more structured. I want to get a real organizing committee around. And some of the things that we'll be taking care of, again, speaking with Brian from Chippy, the things that their board or organizers, whatever, handle are things like the sponsorships and reaching out to sponsors, making sure that there's money to pay for all the kinds of events and things they want to do. Reaching out to venues and things like that for special events. Then also, actually, once you get the money, you can actually do things like flying in external speakers, right? We have a lot of really cool people in Austin Python, but it'd be really cool for us to be able to fly people in remotely, core contributors and other sorts of really cool people in the Python community. And that's a really cool thing that a lot of other big Python meetups do around the country and around the world. There's no reason why we shouldn't be able to do the same thing. Really structuring the job board and the recruiting efforts. I know a lot of people want to recruit here. A lot of people looking for Python talent. Good news for all of us. But we also want it to be structured. We don't want people to get spammed with just job postings all the time when they're very happy with their jobs. But on the other hand, people are looking to find new opportunities. We want to connect them to people who have those opportunities. And then outreach, so cross-pollination with other meetups in the broader Austin technology and startup and entrepreneurship community. And then also increasing our online footprint. Right now, Austin Python, we actually don't have very much of an online footprint. There's not really a structured social media footprint. We don't really, like the talk that Kurt just gave was excellent, fantastic. And that content is now like tears in the rain, right? We don't have that video that we can, put out on the web. And so
it was actually live streamed. It was actually live streamed.
It was live streamed. But those bits are still tears in the rain unless someone downloaded, right? Actually, but we have the opportunity. So Capital Factory has the facilities to do this. We just need to engage with them, get it set up, right, and get these things going. And this is the sort of thing that we have a lot of great presentations, I think, and we really want to have more of that impact online. And then lastly, the AustinPython.org website needs sort of a refresh, and people want to work on a Django project, work on some front-end, back-end type things, and really help us improve the site. It doesn't have to be anything terribly fancy, but just up to date and engaging, letting people know the state of the community. So in terms of membership for people who don't really have the time or the interest to be organizing, and we don't need a lot, we don't need like 100 organizers, we just need a few people, but the key thing about being here is that you sort of have to own it, right? You have to step up, you have to sort of be like, if I'm going to be responsible for X, then I'm responsible for X. And it can't just be, hey guys, I know I'm not getting paid for this, I'm gonna check out this month. So that's the key thing about what we're looking for in terms of organizers. In terms of for the membership, doing t-shirts and stickers and actually having that as be kind of a fundraise opportunity. There's a really cool Austin Python logo that's like on the back of my laptop. We can print more of those stickers and get those out to people. And also, as a fundraising opportunity, we can tell local companies if they want to get their names on the back of the Austin Python shirt for 2015. they can pony up to a certain level on the prospectus. So these are the sorts of things that we can think about when we talk about t-shirts and various kinds of collateral. And also, I want to kind of gauge the interest in other kinds of meetups. So we've talked about this over and over in many years, but for lack of organizational bandwidth, we haven't really done them. But one of the things that Chippy does very well is they have sort of two meetups. One is a presentation format like tonight, like we always do. And another one is a hack night, a project night. People show up and just hack on things. And it could be a weekend. It could be a different location, so people can't get downtown. These kinds of things are really cool to think about. And then also mentorship opportunities, one-on-one kind of things. This kind of ties into this last point. I'm going to go a little bit out of order, but in terms of improving and increasing member interactions, we have a lot of very smart people, a lot of very talented people, a lot of very people doing really cool things. And I would like for people to think about how they want to engage with other people in Austin Python, right? We have a mailing list through meetup.com. There's also a Google group, but there's like very, very little traffic. And it's one of these things where I think a lot of people don't want to step into a cathedral and start yelling because no one's making noises. But actually, I would like for these things to be actually much more active. So I would encourage everyone to post your questions there. If the traffic starts becoming too noisy, everyone can set up their own Gmail filters or whatever, and we can also try to start moderating if it gets out of control. But that's a good problem to have, right? But the other thing is thinking about doing a weekly office hours kind of thing. If people are interested in doing that, it doesn't have a big deal, but it's just a, hey, Austin Python is going to be this coffee shop downtown, or this place up north, this place down south, this day of the week. And it's just a thing where people can go and meet up with other people. I know some people freelance and do a lot of work remote at home. It's nice to kind of have face-to-face interaction with other people. So these are sorts of ideas to think about. Let's talk about this online. I'd love to have more threads going on about these sorts of things and just kind of get more community involvement and really have, what I would like to see in 2015 is for everyone to sort of feel like they're making the meetup itself more of their own kind of thing, and that we're really growing more and more the interactions rather than just a once or twice a month, show up somewhere, see some presentations, here we go on for a while, and then drink some beer. So anyway, that's it. Any questions or comments about any of this stuff?
Sounds like fun.
All right. Well, thanks everyone. Where are we going? Who has an idea for a pub or a big any ideas, suggestions?
Quiet place.
A quiet place.
The Chicago House or Handlebar, right?
We tend to do those. Chicago is very nice when you do that.
How about the tiniest bar in Austin?
It's so cold out. It's like 65. I mean, I don't know that we can schlep that far in this wintry weather. It's a wintry mix, right? Sunshine and. What?
Yeah. Firehouse Lounge.
Firehouse Lounge? Where is that? Let's do the Google map.
Right down the street across. Yeah, it's like a walk and a half away, maybe.
Okay.
The east side of. You have to walk through a bookcase to get to the bar.
You have to walk through a bookcase?
Yeah, it's magic.
Secret entrance.
Platform 9.5? Okay. Oh, it's like right there.
Yeah.
Where is it?
Okay. So we are here at the Omni. And then it's just right here. What, can people see? What are you laughing at?
Not big enough to read.
I can't.
Yeah, it will never be big enough to read.
This inertial scrolling thing plus Google Maps is not. There's no. It has no mass. It's virtual. Okay. All right. Thanks everyone. I'll see you over at Firehouse. Thanks again to Atlassian for sponsoring. Please stand up. Please talk to them if you're interested. Have friends that are interested. And please say that you've heard about the opportunity through Austin Python. And thanks again, Capital Factory. Thank you, everyone.
So we can write a resume generator.